Hello friends, welcome to Shiksharthi. In this video, we shall be discussing the applications of relative velocity. So let's start. Now if you have seen my earlier videos on time, distance and speed, especially the video on relative velocity, in which I have talked about these 3 points. I mean, what is the relative velocity of two things when two objects or things moving in the same direction or opposite direction, and the time taken to meet. And then of course the fourth part wherein we talked about the upstream and the downstream movement. So now in this video we'll be taking an example of a linear motion wherein we can apply the concept of relativity, though relativity is a pseudo concept and we can always talk about real concepts also. So which means what? You can use the real concepts, something that looks to be very real, other than talking about the imaginable part of it and then converting into a reality which is virtual reality. Let us simply talk about things which are very explicit. That is one concept which you can always use. The next concept that we are talking about here is, when we are talking about relativity, we are basically talking about a virtual reality in a certain sense, wherein there is a thought of thing which is a pseudo concept, is an imaginary concept, a false concept. False in the sense it is imagined to be, and then you come out of that concept at a certain point in time. Let us talk about that with the help of an example. So what we are taking here is, let us say that there are two individuals moving in the opposite direction, and here when I say opposite, now I am talking about moving towards each other. So let's say this is a point X and this is a point Y, and these are their destination points. So let's say B starts from here with the velocity VB, and A starts from X with the velocity VA. Now let's say VA is given to you as 6 meters per second and VB is given to you as 4 meters per second, and the distance of separation. So let's say the distance of separation D here is 120 meters. What are we supposed to find out? That we will see. Let it be an open-ended kind of a discussion wherein there is no question which has been given to you, but then whatever we would be inferring or concluding would be type of questions which can be given to you. Okay. Now, since they are moving in opposite directions, so let us say that they are meeting here. Okay, and then we can talk about at how many points would they meet in between. So just for the sake of discussion here, what I am doing is, I have divided this into 5 parts. Why have I divided this? This we will talk about this later. But then if I say VA upon VB can be written as DA upon DB because they are directly proportional to each other, and this will be written as TB upon TA because time and velocity are inversely proportional to each other, and this ratio comes, TB upon TA, and this ratio comes out to be a 3:2. This is using the concept of ratio proportion variation concept. Okay. Second thing now what I can talk about here is time taken to meet for the first time. So what I am putting it as meeting 1. So time taken to meet for the first time will be what? The distance of separation using the formula time taken to meet. And now I want to take it further to a micro level, and the micro level says what? The time taken to meet for the very first time would be how much? The distance of separation plus their individual lengths. So taking their lengths to be negligible. So here we are taking their lengths to be negligible. There are two individuals, let's say two friends, those who want to meet on the way, and they have started from their homes. This is the home for B and this is the home for A. So now in that case, this will be 120 plus 0 plus 0 divided by their relative velocity. Since they are moving in opposite direction, in this case it is towards each other, so 6 plus 4 comes out to be 10. That means the very first time they will be meeting would be after 12 seconds. The very first time when they would be meeting is after 12 seconds. Now, there are many things that can happen after they meet. But let us first talk about their first meeting point. So the time, after the time they have met, so they have met after 12 seconds, what is the distance that has been covered by A? So you will say this is nothing but, when you are talking about distance, so you will say speed of A into the time taken to meet for the very first time. I am putting it as Tm1, which incidentally works out to be how much? How much is 12 into 6? 72 meters. And the distance traveled by B when they are meeting for the very first time will be how much? The speed of B into time taken to meet for the very first time. I hope you would understand that if the time taken to meet is not the same, I mean it has to be the same, because you will say that okay, we are moving towards each other, you talk to each other, and then you say that we'll be meeting after 12 seconds. So the time part has to be kept constant, or it has to be the same for both the sides to conquer. I mean to meet at the same time, to be concurrent at the same time. Otherwise they would never meet. So now in this case, this comes out to be how much? 4 into 12 is 48 meters. Now when I add these two, it should come out to be 120 meters, which it is. So this is the first question which you can get. So as I said, do not be concerned about the questions. We will just keep on discussing things after things. Let us keep it open-ended, because these are the kind of questions which can be given to you. So don't worry about the questions. Worry about the concepts and whether you understand the concepts or not. Now, if I were to say that they continue to move, I mean, when I say they continue to move, that means irrespective of they crossing each other. So here now when I say they continue to move, every meeting point they would cross each other. And they keep on doing this, they reach their respective destinations, they turn back, and they keep on doing this. Please understand it carefully. What I am trying to say now is, let us say they continue to keep on moving, reach their destinations, and then turn back and keep on moving. So let us see the second time when they would meet. They would meet after how many seconds? So now for this, till now you could have said that you are not imagining, I mean you are definitely using the concept of relativity, but you are not imagining it the way you should imagine it. And how do you imagine the concept of relativity? You assume, you put one fellow to rest, is what we had discussed. So the very important part is you put one fellow to rest, and the second important part that we talked about was both of them should start at the same time. They may not start from the same point, which is happening in this case. But two important things are, one of them have to be put at rest, ideally the one who is moving at a slower pace, and they should start at the same time, okay, which is happening. So now I am putting this fellow at rest. So if I am drawing like this, that means this is VB is 0 now, and now in this case we are making this fellow move at VA minus VB, which is VA plus VB in this case, which is 6 plus 4, which is 10 meters per second. So imagine, so this fellow is at rest here. So how easy does it become? So you move from here to here. This is the first time when they meet. So what is when is the second time they are going to meet? 1 is the first time, 2, 3. So how much distance would have been traveled in total? 3D. So let's put it like this now. First time. So meeting, let's put it like this, is meeting. First meeting, second meeting, third meeting, fourth meeting. And this is just to understand it. Okay, and let's talk about what is the distance traveled. So total distance traveled. What is the total time taken? And then you can always talk about individual distance traveled and the individual time taken. So in that case, I am talking about the distance traveled by A and the time taken by A. Or we can divide this further into two parts. Okay, so now the first time they are meeting, let's say the distance here was D The second time when they would meet, so 1, 2, 3, this is the second time, so 3D. This gives me a fair enough idea. The third time they would meet is 5D, the total distance that would have been travelled. Fourth time they are meeting, the distance travelled would be 7D. The nth time they are meeting, the distance travelled would be an odd number, which is 2n minus 1 into d. So now other factors now which come into picture here are, so it was not only percentages, fractions, numbers, ratio, proportions, mixture, alligation, geometry, linear equations, coordinate geometry. Now you even have series, arithmetic series, geometric series, which may also come into picture, which is why we call this topic as a multi-dimensional topic. Now, what is the time taken to meet? So we know that distance is directly proportional to time. So you will see now in this question I am applying both the concepts. I am applying the concept of relativity also, and I am applying the concept of proportionality also, or variation also, or ratios also. So can I use the concept? And for the time being, if I just shelve this discussion, can I say the total time here taken for the first time when they were meeting was t. Second time, we know that distance is directly proportional to t if their velocity is constant, and the velocity is going to be constant because there is only one fellow who is moving with VA plus VB, turning on, coming back, going back, coming back, going back, coming back, and so on. So 3t, 5t, 7t, and so on till 2n minus 1t. Okay, now in this case, the next question which comes up here is, the first time when they are meeting, what is the distance travelled by A? Now when you are talking about the distance travelled by A, this was the virtual side of it. Virtual side was, we were imagining things as we had conceived them. But now you need to come into realism. So when you are coming into realism, it is then you are talking about, okay, what are the individual distances or displacements they would have done or travelled. So talking about the distance that would have been travelled by A in a specific direction, which is I am using capital D. So distance travelled by A, first time they are meeting, let's say 72 meters. For B, 48 meters. Second time when they are meeting, can I say this will be 216 meters and this will be 3. And this should sum up to, so how much does it sum up to? So does it sum up to it sums up to a 360, so which is 3D. The third time when they are meeting is how much? So what I am doing basically is I am using proportions and so on. And same thing I can do for time. So very first time when they were meeting, so very first time when they had met. So this becomes redundant. I mean, when you're talking about time, the meeting time cannot be divided into TA into TB, right? So this becomes redundant, this discussion. So all you need to talk about here is what is the individual distance travelled, and then you can always say that here, can I put it like this, nth time they would have been meeting, if they would have continued to do so as we had discussed, will be 2n minus 1 into 72, and in this case it will be 2n minus 1 into 48 meters. The next thing that we can do here is, from either of the sides, at which point are they meeting? For example, now when I say, so what I am doing here is, I am taking all these as 12, 12, 12. Or anyway, I mean, I can convert this into minute. So let's say 72 and 48. Now I see that all of them, now 72 and 48. Okay, so now the first time when they are meeting, so can I say the first time when they have met? So let's say this was their first meeting point, first time. So this part was 72 from A's side, and from B's side it was 48 meters, is what I was talking about. So the next thing that you can do here is, next time when they are meeting, so this was the first time, so let's say this is the second time when they are meeting, will they be meeting at the same point? Let's check it out. So when I say 216, let's see how do I make a 216. So this is how much, 240, but A is covering how much? A is covering 216. So when A is covering 216, you need to take A how much backwards? 24 units, 24 meters backwards. So in that case, this becomes how much? 96 meters. So this is the second thing that you can do. So from A side, from B side, let's say this is 24 meters and this is 96 meters. This is, I'm sorry, this would not be for this would be for the second time when they are meeting. So let's say this is 24 meters and this is 96 meters, the second time when they are meeting. This is from A side and this is from B side. Now when they are meeting for the third time, so we already have the figures with us. So when they are meeting for the third time, so third time the total distance, so can I say A would have traveled how much? 360 meters and B would have traveled how much? So when A is traveling 360 meters, how will A travel 360? So let's say 120, 240, 360. So where would they meet? This would not be the meeting point. In that case, the third time when they are meeting would be this point, which is the end point. So which is just like saying 120 meters from A side and 0 meters from B side is the next thing that you can do from here. And you can complete this table and take it to its logical completion. Hope you would have enjoyed this video, and if you really feel that something very, very important, knowledgeable has been discussed which takes your learning to the next level, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. Thank you so much. Until next we meet, goodbye.